Imagine a cutting-edge fighter jet screaming through the sky at supersonic speeds, suddenly slowing to a complete stop and hovering in mid-air like a dragonfly before descending gracefully onto a patch of ground no larger than a tennis court. This is not science fiction, it is the remarkable capability of the F-35B Lightning II. This aircraft represents a fundamental shift in tactical aviation, blending the high performance of a conventional fighter with the operational flexibility of a helicopter. Its ability to perform a short takeoff and vertical landing, STOVL, frees it from the constraints of long concrete runways, which have defined air power for over a century. This single feature dramatically expands its potential basing options: austere forward operating locations, decks of smaller amphibious assault ships. The secret to this incredible feat lies in a truly masterful piece of engineering: the Rolls-Royce lift system. Beyond its unique landing capabilities, the F-35B is defined by its low observable, or stealth, technology. The aircraft's very shape is a testament to this design philosophy: carefully angled surfaces, clean lines, and an absence of sharp corners that would typically reflect radar waves. The jet is coated in a specialized radar-absorbent material that further dampens its electronic signature, making it incredibly difficult for enemy air defense systems to detect, track, and engage. This stealth is not merely about invisibility, it is about survivability. This stealthy platform is fused with one of the most sophisticated sensor suites ever installed on a fighter jet. The F-35B is not just an aircraft, it is a flying information hub. Its Distributed Aperture System, DAS, consists of 6 infrared cameras mounted around the airframe, providing the pilot with a seamless 360-degree view of the surrounding environment. This system can automatically detect and track incoming missiles, identify enemy aircraft, and even see through the floor of the cockpit to the ground below. This data, combined with information from its advanced ESA radar and electronic warfare systems, creates an unparalleled picture of the battle space for the pilot. The interface for all this information is another revolutionary component: the pilot's helmet. All critical data, airspeed, altitude, targeting information, and threat warnings is projected directly onto the helmet's visor. When the pilot looks at a target, they can lock on with a simple voice command or button press. The F-35B's most profound impact is arguably on naval warfare, where it has completely redefined the concept of an aircraft carrier. For decades, only the world's largest and most expensive supercarriers could operate high-performance, fixed-wing jets. The F-35B changes this paradigm entirely. Now, smaller amphibious assault ships, America-class, Queen Elizabeth-class, can be transformed into light aircraft carriers. Previously limited to helicopters and slower jets like the Harrier, they can now deploy a squadron of 5th-generation stealth fighters, granting offensive capability, granting defensive capability. This development acts as a massive force multiplier. Nations can distribute naval air power across more platforms, making fleets less concentrated and less vulnerable to a single decisive attack. Lightning carriers can deploy to different regions simultaneously, providing presence, deterrence, rapid response. They can support amphibious landings, conduct sea control operations, project power inland, all with the survivability advantage of stealth. The F-35B does not require catapults or arresting gear. That simplifies flight deck operations, allowing quicker turnaround and potentially increasing sortie generation in a high-tempo conflict. The extraordinary capabilities of the F-35B come with an equally extraordinary price tag. The aircraft is one of the most expensive weapon systems in history. Its unit cost has been intensely debated since the program began. Beyond the purchase price, operational costs are substantial, driven by the complexity of its advanced systems and specialized maintenance required for stealth coatings. High engine fuel consumption also drives costs. These life cycle costs mean long-term financial commitments for buying nations. The program's development was long and arduous, marked by technical challenges. Software glitches caused major headaches early on. Problems with the helmet display drew criticism, and the logistics system had serious issues too. Critics questioned the program's viability, yet integrating stealth, sensor fusion, and vertical lift into one airframe was an engineering feat. The result was immense complexity. Many initial problems were later resolved through testing and software updates, but the program remains a case study in the cost of pushing aerospace boundaries. The F-35 is also a massive international cooperative program. 9 partner nations contributed to development funding and manufacturing: the United Kingdom, Italy, the Netherlands, Australia, among others. This global supply chain is both a strength and a vulnerability, creating a complex web of industrial dependencies that can be impacted by politics or manufacturing issues. The F-35B, like any modern weapons system, is not a static design. It is built to evolve. The aircraft's true power lies not just in its current hardware, but in its software-defined architecture with periodic block upgrades that continuously enhance its capabilities. Improve its radar performance, refine its sensor fusion, enable it to carry new weapons, enhance its electronic warfare suite. An F-35B built today will be far more capable a decade from now, without a costly physical overhaul. One standout fact: it can land on a moving ship deck. That deck measures about 200 feet long, roughly the length of 7 city buses end to end. The jet's flight control system is incredibly advanced. It can automate much of a vertical landing at sea, compensating for wind, ship movement, and air turbulence with thousands of micro-adjustments per second. Pilots can land safely in conditions impossible for earlier Stoviel jets. It's not just possible, it's reliable and all-weather. Looking forward, the F-35B becomes a pillar of future combat concepts, especially human-machine teaming. The pilot's role is shifting from stick-and-rudder flyer to battlespace manager. Soon, a pilot could command a swarm of wingman drones from the cockpit, to scout, to jam enemy radars, to carry extra munitions, extending reach and keeping the pilot out of immediate danger. Powerful processors and data links make this possible. In conclusion, the F-35B Lightning II is far more than another fighter. It is a flying nexus of stealth, advanced sensors, and unprecedented basing flexibility, the embodiment of air power, unchained.